Sleep quality plays an important role in an individual's ability to inhibit cognitive interference, or a person's ability to ignore unnecessary information when performing a task. Poor sleep quality is believed to lead to an increase in cognitive interference. We can measure cognitive interference through a Stroop task, which requires a participant to read a color word that is printed in a certain ink color. For example, the word yellow may be printed in the color green. The participant is required to respond to the print color, which is green, and not the word yellow. The Stroop task features congruent and incongruent trials. Congruent meaning that the word and the print color are the same, and incongruent meaning that the word and the print color are different. Slower reaction times are more often observed in incongruent trials, indicating higher cognitive interference. There has not been much research done on the relationship between sleep quality and the Stroop effect, and we also found some conflicting evidence in the research involving sleep quality and cognitive interference. Some say that there is no effect, while others emphasize a strong relationship. The purpose of the current study was to fill in this gap in information. We hypothesized that sleep quality would be negatively correlated to reaction times in a Stroop task. Specifically, we believe that poor sleep quality would lead to slower reaction times. For this correlational study, our dependent variable was inhibition of prepotent response, operationalized through response time, and the independent variable was sleep quality. We gathered data through a convenient sample by sending out a survey through Reddit and Facebook. Our final sample consisted of 31 participants made of 11 males and 21 females. Participation was remote, took only 5 minutes to complete, and instructions on how to complete the survey and the Stroop task were provided. All variables were measured and operationalized using the online software Sci Toolkit, and RStudio Cloud was used to analyze the data. For sleep quality, we asked 10 survey questions measured on a Likert scale. For the Stroop task, there were 40 trials varying in congruency. A Pearson's R correlation statistical test was used to analyze the data. The mean for the sleep quality scale was 13.56 and a standard deviation of 4.5. We found that there was no significant correlation between participants' sleep quality and their response times on the Stroop task. The p-value, as you can see, is not significant at 0.92. The data does not support our hypothesis that sleep quality has a negative correlation to response times on a Stroop task. This study has low external validity because we use convenient sampling, which could have led to a lack of relationship shown in the final dataset. Future studies should feature a more representative sample and also include a more controlled environment to take the experiment and survey in.